Hello, young math Padawans. In this video, we are going to take a closer look at using the properties of equality to solve equations, specifically our addition and subtraction properties of equality. Just as a quick reminder, here are the two properties of equality. Take a moment to read through both. Okay, so to begin our notes, we do have two important vocabulary phrases here. The first one is, what does it mean to solve an equation? So solving an equation means to use the properties of equality to isolate the variable and determine the solution. So solving is a process. A lot of times we can figure out the solution by looking at the equation, but to solve means to show the process. The second vocabulary term is solution, and solution is the value of the variable that makes the equation true. And the key word really here is true. So let's look at equation 1. Equation 1, we have x plus 10 equals 21. Looking at this equation, can you tell me what x equals here? What is the solution? Many of you can look at this equation and tell me that x must equal 11 because 11 plus 10 is how we get 21. That is an awesome skill. Now let's go in and apply the properties of equality to get to that solution to show the process of solving. I always put a line down the middle of my equal sign to keep the left side separate from the right. And now I have to determine which property of equality am I going to use. Am I going to apply addition property of equality or subtraction property of equality? Let's try addition first. If I come in and add 10 to both sides of the equation, does that solve it? Well, let's see. This becomes x plus 20 equals 31. It's an equivalent equation, meaning x still equals 11, but it hasn't been solved. So addition property of equality did not work here. So let's try the subtraction property of equality. If I come in and subtract 10 from both sides of the equation, what does it look like after I simplify? Well, I'm still left with x. 10 minus 10 is 0, and 21 minus 10 is 11. And I can simplify x plus 0 to just x, because anything plus 0 is itself. So now I have solved the equation. So what are these reasons? These reasons are basically stating what we did here. The first thing we did is we chose to apply the subtraction property of equality. That's giving a reason for that step right there. And then after we did the subtraction property of equality, we did the math. We did the subtraction. That in math is called simplify. Simplify means do the math. Now, before we can just accept that this is true, it's important to check the solution. Actually plug it in and make sure that it makes the equation true. So if our original equation is x plus 10 equals 21, and if I were to substitute 11 in this equation, is it still true? Well, does 11 plus 10 equal 21? Yes, it does. Which means what I like to do next is put a box around my solution, because this is the value of the variable that makes the equation true. And this is the process of solving. Let's look at equation 2, very similar to equation 1. Now, looking at this equation, x minus 10 equals 21, can you figure out the value of the variable that makes this true? Some of you might have, and some of you might be thinking, ooh, that's subtraction. I'm not sure, so maybe we're not sure on this one. However, we do know that we're either going to apply the addition or the subtraction property of equality to solve this equation. The first step is always the same. I put a line down the middle of my equal sign to separate the left side from the right. I highly recommend doing this. Now, I see subtraction here, so I figure let's try subtraction first. What if I were to subtract 10 from both sides? careful here. This is a negative 10 in that top equation. So when I go in to simplify, I have x minus 20 equals 11, because negative 10 minus 10 is negative 20. Now, I have an equivalent equation here. However, it's not a solved equation. So it doesn't appear SPOE was the correct property to use. So that leaves us to try using APOE. What if I add 10 to both sides and simplify? Okay, I'm left with x. And then again, recall that this is a negative 10. Negative 10 plus 10 is 0. And 21 plus 10 is 31. And then anything plus 0 is itself. So x plus 0 is x. And it appears I have a possible solution here. Okay, x might equal 31. So let's go in and put in our reasons. I applied the addition property of equality, and then I simplified, or I did the math. To see that my math is correct, and before I can put a box around my answer, I'm going to check that solution in the original equation. So plugging in 31, does 31 minus 10 equal 21? Yes, it does. Therefore, this is the correct solution. 31 is the correct solution to this equation, and I know that my work was done correctly. Moving on to equation 3 and equation 4. Let's start with equation 3. I'm either going to apply the addition property of equality or the subtraction property of equality to solve this equation. All right, well, I'm going to put my line down the middle of my equal sign, separate the left side from the right. What does x equal in this equation? 5 plus what equals 13? Doesn't 5 plus 8 equal 13? Yeah, I think that's true. So we know what the solution is. That makes our job a lot easier. Now we just have to figure out which property allows us to get to that solution. Let's try APOE. If I choose to add 5 to both sides of this equation, what does that give me? 5 plus 5 is 10. Bring down x. And 13 plus 5 is 18. Now, this is an equivalent equation because 10 plus 8 is still 18. But is it a solved equation? No. So APOE was not the correct property to use here. So let's try SPOE, subtraction property of equality, and subtract 5 from both sides. All right, 5 minus 5 is 0. 0 plus x equals 13 minus 5. That's 8. And what is 0 plus x? That's just x. So by subtracting, I was able to isolate the variable, and I ended up with our solution. So we applied the subtraction property of equality, and then we went in and simplified. We did the math. But before we put a box around it, let's make sure that that math was actually correct. Here's the equation I started with, 5 plus x equals 13. And I'm going to check if 8 makes this equation true. Does 5 plus 8 equal 13? Yes, it does. So I can go and put a box around my solution. X equals 8, and I've now shown the process of solving. What about equation 4? Negative 5 plus x equals 13. Do you know what x equals in this equation? I don't. Anything with negatives becomes a lot tougher to me. So now I'm just going to figure out, am I applying the addition property or subtraction property to solve this equation? I always start with a line down the middle of my equal sign. And let's try addition property this time. What if I add, should I add negative 5? No, that doesn't sound right. Let's just add 5 to both sides. As soon as we start adding negatives, then things become way more complicated and we're really using subtraction. So let's just keep it simple. Let's simplify. Negative 5 plus 5 is 0, plus x equals, and 13 plus 5 is 18. I can simplify this further because 0 plus x is just x. And I ended up with x equals 18. I don't know if this is correct, so let me just put in my reasons and then we'll check our solution. We applied the addition property of equality, and then we did the math and simplified as much as we could. Only one way to be sure. Let's take our original equation and substitute in the solution that we got. Let's plug in 18 for x and see if it's true. Negative 5 plus 18 equals 13. Ooh, that's kind of a tough one. Well, this might make it a little easier. Whenever you're adding a negative, you can actually switch these around. This is the same as 18 minus 5. And does 18 minus 5 equal 13? Yes, it does. This is a true equation, which means 18 is the solution here. Final equation and final example. Negative 6 equals x minus 5. Ooh, this time the variable's on the other side. Can you figure out what x is in this equation to make it true? I sure can't. That's a lot of negatives. I don't want to deal with it. So let's put a line down the middle of our equal sign and figure out which property of equality we're going to use, APOE or SPOE. But this one's weird too, because am I applying it with 6? Or am I applying it with 5? This is where math gets complicated. So here's what I'm going to do. I'm going to think ahead. Notice that x is on the right side of the equation. And so I want x to stay on the right side of the equation. So let's see what allows us to keep x there. I'm going to start with APOE. Now, what if I chose to add 6 to both sides of this equation? Negative 6 plus 6 is 0. X is still on the right. And careful, that's a negative 5. Negative 5 plus 6 is 1. Have I solved this equation? No, I've created an equivalent equation. It still has the same solution, but I'm nowhere near closer to solving. So APOE with adding 6 didn't appear to do anything. So let's try something different. What about SPOE with 6? Subtract 6 from both sides. Again, keep in mind that's a negative 5. That would give me negative 12 equals x minus 11. Darn, another equivalent equation, but nowhere near where we want to be. Okay, so that leaves us to try things with this 5. So I'm going to start with APOE. What if I added 5 to both sides? Negative 6 plus 5 is negative 1. Bring down x, and again, this is a negative 5. Negative 5 plus 5 is 0. I can keep simplifying here because x plus 0 is equal to x. So x equals negative 1. Okay. I think I may be onto something here. So we applied addition property of equality, and then we went in and we simplified our math. But there's only one way to be sure. I have to check my solution. So in the original equation, I'm going to substitute negative 1 for x. And if it's right, I did my math right. If it's wrong, we got to try again. So does negative 6 equal negative 1 minus 5? What is negative 1 minus 5? You know, I like to change this whenever I see subtracting with negatives. I like to change that to adding a negative 5 because negative 1 plus negative 5 is easier math for me. Negative 1 plus negative 5, that is negative 6, which means we did our math correctly. That's it for today's lesson. I will see you next time.